Hello everyone, today we're going to be going over the Grignard reaction. This is a reduction of a ketone or an aldehyde. As we'll see, any double bond O, we can use the Grignard's reagent and reduce it into an alcohol. So if you watched my preparation of the Grignard's reagent, you remember how we made the Grignard's reagent here through using magnesium. So, if you didn't watch that video, I highly recommend it, but hopefully you know that this R group here is going to be negative and this is positive. And just to let you know why, you might look at that and be like, well, that should be a covalent bond. Well, it's not, because magnesium and R, right? If R is just some carbon chain, that means carbon is roughly, how many Paulings? It would be 0.73 magnesium to carbon, but since we have bromine, it adds induction, and that makes it very polar to the point where we can basically treat it as ionic. It is borderline ionic. I mean, the R group, which would be a carbon, is just hugging those electrons real tight. Magnesium's like, no, don't go, electrons, I don't want you to go. Right, so remember, it's just ketone or aldehyde, it's an alcohol, and the addition of that R group. So let's look at the mechanism here. It's quite simple. If we recall that this is negative, this is positive, that R group basically has a set of lone pairs. So through a simultaneous process, R group's gonna attack that carbon, right? And why is it gonna attack that? Well, this is partially positive, this is partially negative, right? Because oxygen's electronegative. And in a carbon-oxygen bond, that oxygen is like, give me those electrons, give me those electrons. Well, carbon's like, no, don't take them. I mean, you kind of can, but don't take them, right? So that partial positive charge attracts that carbon, which, you know, if carbon has a negative charge, it is a strong nucleophile. It does not like that. It's like spraying a cat with water. That's a very bad idea. So the R group attacks, and right, if this were to just form, it would form a full positive charge on that carbon. No bueno. So what's going to happen is these electrons are going to kick up to the oxygen. Sorry, it's not going to make a positive charge, it's going to make a negative charge, right? And that means that because oxygen likes a negative charge more than the carbon here, it's going to kick up and form an oxide ion. Should probably draw this with the right geometry. It's been a rough day, guys, I'll tell you that much. So we get a negatively charged oxygen, and now we have R. R is bound. What happens next? Well, we know oxygen, it does like a negative charge, but if it could choose not to have a negative charge and bind to something, that would make it a lot better. So we use an acid, some sort of acid, just get protons in the solution, quite simple. These lone pairs reach out to the hydrogen atom, it's like, hey buddy, you wanna share some electrons? And the oxygen's like, not my proton, guys, come on, that's not cool. Bro stole his proton. Anyways, this is an okay thing because we know that this acid here is positively charged. It gives the incentive for that oxygen to just lose that hydrogen, and it neutralizes both compounds. And what we get is an alcohol. All right, another thing that I wanted to point out, right, now that we looked at the mechanism going from the ketone or aldehyde into an alcohol and adding on the R group, I want to go over oxidation states because you need to know why we call this reduction, right? We just need to look at the oxidation state of this carbon here to explain this. So carbon here usually is going to be +4. Oxygen takes some away, that makes it +2. We have a +2 oxidation state here. And when we get to the alcohol, assuming this is some carbon chain R, that means that there's no net oxidation state contributor with this bond here, this one or this one. And the oxygen, of course, takes one. So it takes on a +1 oxidation state for that middle carbon. So if we go from +2 to +1, that's reduction. even though it's not that significant, it's reduction, and that's why we call it a reduction of a ketone, right? So, hopefully you found this video helpful. If you did, please like, subscribe, anything to support, I'd really appreciate it, and have a wonderful day.